In the frozen trenches of World War I, heat was not a comfort issue. It was survival. Soldiers faced weeks of rain, sleet, snow and wind, with no reliable shelter, limited fuel, and the constant threat of exposure. Standard campfires failed immediately in these conditions, either drowned by rain, blown apart by wind, or spotted by enemy observers. Yet across the western and eastern fronts, soldiers quietly relied on a simple heating solution that worked in mud, snow, and storms alike. The barrel stove was not a piece of issued equipment at first. It was a field-expedient system, refined under pressure, and it succeeded because it controlled three things open fires never could: combustion, airflow, and heat retention. The trenches were cold sinks. Wet earth pulled heat from the body, wind stripped warmth from clothing, and standing water made everything worse. Fires built in the open trench floor were useless. They smoked heavily, burned fuel too fast, and attracted artillery fire. Soldiers needed a heat source that could burn low, stay hidden, and operate in all weather without constant attention. The solution had to use whatever materials were available, often scavenged under fire. Metal barrels were everywhere. They carried fuel, food, oil, and supplies. Once emptied, they became raw material. Soldiers learned that a steel barrel, when laid horizontally or stood upright with controlled openings, could function as a contained stove. By cutting a small fire door near the base and a flue opening near the top, they created a combustion chamber protected from wind and rain. This simple enclosure transformed unreliable fires into dependable heat sources. An open fire loses most of its heat to the air. The barrel stove trapped heat inside metal walls, forcing it to radiate outward slowly. Wind no longer stripped flames apart. Rain could fall directly on the barrel without extinguishing the fire inside. The metal heated quickly and, stayed warm long after the flames dropped. This allowed soldiers to burn smaller fires for longer periods, conserving fuel while still maintaining steady warmth. The real trick was airflow discipline. The fire door was kept small, often partially closed with a scrap of metal. This limited oxygen, slowing combustion, and, reducing smoke. A narrow chimney pipe, sometimes improvised from stovepipe sections or rolled sheet metal, carried smoke upward and away from the trench. Even without a full pipe, soldiers used angled exhaust holes to guide smoke low and disperse it. This made the stove usable in rain, snow, and high winds without drawing attention. Barrel stoves burned anything, Scrap wood, broken crates, coal fragments, dried roots, just about whatever was at hand. Even soaked timber could catch once the barrel was hot enough. The enclosed environment allowed wet fuel to dry as it burned, making the most of every bit of warmth. Soldiers learned to start fires with small dry kindling, then feed in damp material gradually. The barrel's retained heat drove off moisture instead of letting it smother the flame. It was a bit of a knack, but once you got it, you could keep a fire going with almost anything. The stove was rarely placed in the open trench. It was installed inside dugouts, bunkers, or reinforced shelters cut into trench walls. Heat radiated from the barrel into the confined space, warming air, drying clothing, and preventing frost build-up. For many, it was the only comfort during those long, bitter nights. Soldiers often placed stones or bricks around the barrel to absorb heat and release it slowly, extending warmth through the night. In deeper dugouts, the stove transformed damp, freezing holes into livable spaces. Cold alone was not the main threat. Persistent dampness caused trench foot, respiratory infections, and exhaustion. The barrel stove dried socks, uniforms, and blankets. This mattered more than raw temperature. Soldiers who could dry their clothing avoided injury and stayed functional longer. Medical reports from the period consistently link warmth and dryness with reduced non-combat casualties, and the barrel stove played a direct role in that outcome. Fire inside confined spaces is, well, dangerous, and World War I soldiers learned caution pretty quickly. Stoves were elevated slightly off the ground, to prevent heat transfer to the wooden supports. Chimneys were angled carefully so they wouldn't end up igniting the roofs. And fires, they were always kept small and controlled. Most importantly, ventilation was never, ever sealed. A steady airflow prevented carbon monoxide buildup, which, honestly, could be deadly. These practices weren't just theoretical. No, they were enforced by hard experience. The same principles apply today, really. A sealed metal container with controlled air intake and exhaust can provide reliable heat even in the worst weather. Modern users can adapt steel drums, ammo cans, or heavy metal boxes into safe stoves, as long as they use proper flues and spacing. So, the key lessons remain unchanged: enclosure, airflow control, and thermal mass. This method works in snowstorms, rain and wind because it isolates the fire from the environment rather than fighting it. The barrel stove was not elegant. It was not designed by engineers. It emerged from necessity and, well, it stayed because it worked. It turned waste material into warmth, conserved fuel, and operated under the worst conditions imaginable. Its success reminds us that effective technology does not need to be complex. It needs to be controlled, repeatable, and understood. This knowledge survived because soldiers depended on it. In an age of disposable gear and fragile systems, the World War I barrel stove stands as a reminder that reliability is built, not marketed. If this deep exploration of wartime survival engineering added value to your understanding of history, support in the beginning by subscribing, sharing this episode, and helping preserve practical knowledge that still matters today.